Welcome, dear students, to chapter 8 of your book. The title of the chapter is Motion. Today, in this chapter, we will be learning about motion. What is motion and what are the different types of motion we will be knowing in this chapter. Dear students, in our everyday life, we see some objects which are not moving and some objects which are moving. Now, those objects which are moving in physics, they are termed as to be in motion, like birds fly, fish swim, the blood flows through veins and arteries, and even the car moves. And if we go in the more minute structures than atoms, molecules, these all things they are in continuous motion. And we often perceive an object to be in motion when its position changes with time. So that is the first line written here. Motion is defined as the change of position of an object with time with respect to its surrounding. Similarly, an object is at rest when the position of the object does not change with time. For example, we infer like the motion of air by observing the movement of dust and movement of leaf and the branches of tree. So we say that moving air is moving and it is in motion. So similarly, there are many phenomena which we can see like moving and some at rest. Those which are in moving position, they are said to be in motion, and those which are not, they are seen to be in rest. An example is furnished here where you can see that a moving train is in motion because its position changes with time. Now, if you consider a person sitting in the train, for someone standing on the platform, the person sitting in the train is in motion. But for the co-passenger, the person is at rest. Means if in a train two persons are sitting on opposite berths, then for both of them they are at rest. But if anyone is observing them from the platform, then both the persons are in motion. So we need to consider the surroundings or the point of observation while we have to describe the motion of any object, and this surrounding is called the reference frame. Now, types of motion actually it is broadly classified into three main categories. Further we'll be looking into more categories of its classification, but here the three main categories are translatory motion, where the motion of the particle moves in a straight line. Next is rotational, where the body moves around a fixed axis in circular way. And the last one is periodic motion, where it refers to the motion which repeats after a certain interval of time, where the example can be that of a swing or a pendulum. These are the examples for periodic motion. Also, motion can be classified as non-uniform motion, like if a body covers unequal distance in regular interval of time. If an example is to be given, then suppose a person is there who travels for suppose 2 hours he is traveling and he has covered suppose 5 kilometers in 2 hours. Then for the first hour he has traveled 3 kilometer, and for the second hour he has completed 2 hours, 2 kilometers. Then here the distance travel in both the hours is different. Like in the first hour he has traveled 3 kilometer, and in the second hour he has completed 2 kilometers. So here he has not covered equal distance in equal interval of time. So this type of motion is said to be a non-uniform motion, and if we draw a graph of this non-uniform motion along time and distance, then you can get some this type of picture. Another one is your linear motion. Linear motion means it is a in a straight line, or like the word linear means straight and the word motion means change in position. So if a body moves in a straight line, then that motion is said to be linear motion. Here some points is given to be remembered that in linear motion the object must move in straight line, and the motion of the object along the straight line it may not be uniform. Means the motion it cannot be uniform, but it should move in a straight line. Next is your uniform motion. Uniform motion means if a body covers equal distance in equal interval of time, like covering a distance of 3 kilometer in 3 hours, एक घंटे में 1 किलोमीटर, दूसरे घंटे में 2 किलोमीटर, तीसरे घंटे में 3 किलोमीटर. So per hour they are traveling equal distances. So this type of distance is known as uniform motion. Like here an example is given. You see, a person starts from 10 a.m. At 10:15 he has completed 10 kilometer. Then at 10:30 he has 20. Then again at 10:45 he has 30. Then at 11 he has completed 40 kilometer. Then you see at every interval of 15 minutes he is covering 10 kilometer. So at every interval of time the distance traveled is equal. So this type of motion is known as uniform motion. Next we have physical quantity. Now, a physical quantity is any physical property which can be expressed in numbers. Like it can be distance, it can be weight, it can be anything which can be expressed using number. An example is given here, like time. If we have to express time, we used to say that it's 2 or 10 or 215 or 220. Similarly, if I say that what is the quantity of anger that you have, you cannot express using numbers. So those quantities which can be expressed using numbers, they are known as physical quantity, and those which cannot be expressed, they cannot be regarded as physical quantity. Now physical quantity is again classified into two types: scalar quantity and vector quantity. What are they? We'll be looking into them one by one. Scalar quantity. Now if a physical quantity, it can be completely described only by the magnitude without the help of direction, then that is known as scalar quantity, and in that case you have weight. Weight, or the measure of mass of an object, it can be said as scalar quantity because you don't need to mention that along which direction you are measuring. Suppose if a book is to be weighed, you just weight it and you will say that it is 2 kg. You are not going to say that I have measured it along the right side, along the left side. Means if the weight is 2 kg, means the complete weight is 2 kg. Another one is your vector quantity. Now in case of vector quantity, there are certain physical quantities which can only be explained if the direction is mentioned. They cannot be mentioned using only their magnitude. So these physical quantities which require direction along with the magnitude, they are known as vector quantity. Like force. Here an example is given. See, a donkey is being pulled by a person. So the force is being applied towards the person. So this type of quantity is known as vector quantity, where the direction is also of equal importance to express it. This type of quantity is known as vector quantity. Another one is now your distance and displacement. Now distance, it means the length of the path, or the path length which is traveled by a body while moving from an initial position to a final position. Means here you see, suppose this is the house of one person, this is the house of another person. Now the straight line which connects between these two, this is the shortest distance between these two houses. Now if this shortest distance between these two houses, or the shortest distance between any initial position and final position, that is known as displacement. Now if I want to go from this house to this house, now if I choose this path, like I'll go in this way, I'll roam and roam and roam, and then I'll go this way, then this is the total distance that I have traveled. So the difference between distance and displacement is that displacement is defined as the shortest distance between initial position and final position, and distance is the length of the path, or the path length which a body travels. Suppose the distance between two houses is 2 kilometer. It means that the pathway of choosing to reach from one house to another house, the complete distance to be traveled is 2 kilometer. Now displacement means what is the shortest way to reach that place, that is the displacement. Now displacement is a vector quantity, but distance is a scalar quantity, because in case of distance you will mention only the distance that you have traveled, like the distance from school to your house is 2 kilometer. But if I am saying that the displacement is 1 kilometer, it means that you have chosen some other shortcut way. So that shortcut path, you have to mention that in this distance, means in this direction, the displacement is 1 kilometer. So that is a vector quantity. Displacement is vector, but distance is scalar quantity. Next is your speed. Now speed is defined as the rate of distance which is covered by a body. Mathematically, speed is given by speed is equal to distance by time. Means if you are given time and if you are given distance, then to calculate speed you just need to divide the distance divided by the time. Given that the unit will be either in second, minute, and the distance unit will be in kilometer or meter. Now mathematically, the average speed is calculated as total distance traveled by the total time taken. Means average speed is given by the formula of total distance by total time taken. Now acceleration, similarly acceleration is defined as the rate of change of velocity. Now acceleration is a vector quantity and it has a direction. The acceleration for any substance is given by acceleration is equal to change in velocity by time taken. Now here a formula is given for calculating the acceleration of a body. Now this mathematical part we will be doing in the next video, where I'll be telling you about the change in velocity and three equations of motions that we have and how their derivation is done. So you are asked to go through this video and see this and read the chapter 1 so that it will be more clear to you. So thank you for watching up to here. Thank you.